So for this equation, or this graph, we are going to take a look at the y-intercept. So we're exploring y-intercept form. So you can see right here, this 6 is our y-intercept, which is otherwise known as b. So if I'm writing my equation, y equals x, it's positive, so it's going to be positive 6. So my equation is y equals positive 6. That positive 6 is my y-intercept. It's the place where the line is hitting the y-axis. All right. Let's look at the next one. Now we're going to look at some tables, and we're going to identify the y-intercept from tables. So with this, you're looking for, again, the relationship between x and y, just like we did when we were looking for slope. But now we're looking for the y-intercept. And since we know the slope is going to be x, or 1x, all we're really trying to figure out is what we're adding. So if you look at this table, you can see from 0 to 3, 1 to 4, 2 to 5, it's a plus 3 relationship. So since it's a plus 3 relationship, our y-intercept is 3. And then if I write the coordinates of that, it's going to be 0, 3, because my y value is 3 when x is 0. If we look at the second table, same thing. We're looking at the change from x to y. And x to y, we're going to have a plus 6 relationship, plus 2 relationship, because 4 plus 2 is 6. So that means my y-intercept is 2, and the coordinates are 0, 2. Now, if you're not sure about what the y-intercept is, but you know that it's additive, one thing you can do to get b, just like for slope, you can divide y by x. For b, you can actually subtract y minus x. So we could do y minus x. So if I substitute y, I could take 6 minus 4, and I still get that value of 2. So when in doubt, subtract x from y. So that's a good example of when we might use that here. So if I'm going to take y minus x here, I'm going to take the table. I can just take any of the values. I'm going to take 4.5 and subtract 4. And so my y-intercept is going to be 0.5. So I'm going to put that here, 0.5. And then my coordinates are 0 and 0.5. Last one. Again, to get my y-intercept, I'm looking for the relationship between x and y. If I'm not sure, I can take y and subtract x to figure out what number I was adding or subtracting. So I'm going to take negative 3 and subtract 6. Okay, so if I take negative 3 and subtract 6, I can do that on my Desmos calculator. So negative 3 minus 6, and you can see negative 9. So negative 9 is going to be my y-intercept because I'm subtracting 9. So b is negative 9, and the coordinates of my y-intercept are going to be 0, negative 9. Okay, so that's how we find y-intercept from a table. Remember, the difficult thing is going to be determining whether it's multiplicative or additive. If it's multiplicative, you're going to find slope. You divide y by x. And if it's additive, like these examples with y-intercept, you're going to subtract x from y, or simply find what you would add to x to get y. All right, now we're going to look at some word problems. We have some hints here. We're going to look for multiplication words. So just, look at these hints. These are going to be helpful. The most helpful thing, though, that I see here is the formulas. So we have the formulas for slope. Right here, the slope formula is y equals mx, and then the y-intercept formula is y equals x plus b. Another way to think about this is our slope formula is also, if it's proportional, we're going to use y equals mx. And if it's additive, we're going to use y equals x plus b. So let's take a look. Hosu earns $9 per hour when he babysits. We're going to let x represent the number he babysits and y the amount he earns. So we're looking for the equation that best represents it. Well, it tells us here that x is going to represent the number of hours. So it's going to be $9 per hour, so it can go back to the original equation. I'm going to put an x there because I know I'm doing something with 9 and x. So to figure out what I'm doing with the numbers, sometimes it's helpful to think about how much it would be for 1 hour, or make a little table over here. So if Hosu works 1 hour, he's going to make $9. Okay. If he works 2 hours, he's going to make $18. So let's think about what we're doing here so that we can figure out the equation. We're multiplying. Okay, so since we're multiplying, we're going to choose this one, y equals 9x. We're multiplying 9 by the number of hours in order to find out how much he's going to earn. Okay, let's look at the next one. Penny's dog was already 4 years old when her family adopted her. X is going to represent the number of years Penny has her dog, and Y is going to represent the age of her dog. So for this, I'm going to think about already 4. Okay, maybe it's addition, maybe it's multiplication, I'm not sure. So again, a helpful thing for questions like this might be to make a table. So X would represent, we said, the number of years. So I'm going to say, okay, at 0 years, how old would Penny's dog be? Well, it tells us in the problem that Penny's dog was already 4 years old, so at 0 years, the age of the dog would be 4. At 1 year, okay, 1 more year goes by, the age of the dog is going to be 5. At 2 years, 6. So if you're having trouble coming up with the equation, you can take the context of the problem, create a table, and now I'm going to relate my x with my y value. So you can see that the numbers are changing by 4. So we're adding 4 each time the x value increases by 1. So since we're adding 4, this is going to be an additive relationship, and our equation is going to be y equals x plus 4. The next one, we have Ellie's parents give her $5 for every A she earns on her report card. So we can take a look at this. $5 for every A, and we're trying to figure out X is the number of A's, so I'm going to use X for the number of A's, and that $5, we're going to do something with that, and then that's going to give us the total amount. So again, we might think about this in terms of, okay, if Ellie makes 1 A, or 0 A's, how much money is she going to get? She's not going to get any money. She's not going to start out with any money. It's $5 for every A. So if she gets 1 A, she's going to make $5. She gets 2 A's, $10. So again, we can see that this relationship here, our number from 0 to 0, 1 to 5, 2 to 10, it's going to be a times 5 relationship. So we're multiplying the 5. We're multiplying the 5 here. So since we're multiplying the 5, we're going to choose this one, y equals 5x. Last problem, Ed got 8 extra credit points on his last test because he turned in his study guide. Something you guys should be doing, turning in your study guide, you get extra credit. He also earns 1 point on the test for every question he gets correct. So we're going to let X represent the number of questions he answers correctly, and Y is going to represent the total points he earned. So he's starting out with 8 points. So that's our starting point. Okay, if you look over here in our hints, it says look for words to signal a starting amount or addition. Okay, so he's starting with 8 extra credit points. So this is going to be an additive relationship, because if he gets no questions right, think about it. If he has 0 questions, if X is representing the number of questions, he gets 0 questions right, he's still going to get 8 points on the test. If he gets 1 question right, it tells us it's 1 point per question, so that would be 9. So you can see that this is a plus 8 relationship because our starting point was 8. So we're going to go with A, y equals x plus 8. All right, let's look at the next section here, section 4. We're going to graph slopes and points. So you have, again, some hints here. If you're given a point and a slope, you plot the point first. Okay, we haven't changed the way we plot coordinates. We're still going to plot points. We're just making lines, sometimes using slope, sometimes using our y-intercept. So remember, if given a point and a y-intercept plot, both remember you have the y-intercept has an x value of 0. So you're hitting the y-axis at the number that's given. So let's go ahead and get started. We're going to graph the line that goes through -6, -4. Now, -6, -4, that is not slope. That is a coordinate. We're going to graph it just like we would anytime we have a coordinate. And coordinates are going to be x, y. So I'm going to go -6 on the x and -4 on the y. -6 on the x, -4 on the y. So I'm going to plot my point right there. All right, and it tells us we have a slope of 2. So if we have a slope of 2, that means m is going to be 2 over 3 because it's my rise over run. So I'm going to go up 2 over 3, up 2 over 3, and then I'm going to make my points on my graph. If I connect those points, you can see that it's proportional. We used our slope, up 2 over 3, to get our other 2 points. Okay, so let's take a look at our next problem. We're going to graph a line that goes to the point. Again, this is a coordinate, -4, -3. So I'm going to graph that point, -4, -3, where they meet. I'm going to put a point. Okay, so I've graphed the point, and it tells me that it has a y-intercept of 2. So remember, if it has a y-intercept of 2, it means it's going to hit the y-axis at +2. So I'm going to put a point at +2. The coordinates of that would be 0, 2. All right, so I have my 2 points. I'm going to simply put a line through them. And there's my graph. It has the point -4, -3. Again, that's not slope. This is not slope. It is just a coordinate that we are graphing. And when we graph coordinates, we graph them x then y. Okay? Where slope is rise over run, coordinates are x then y. Next one, we're not given, we have our equation y equals x minus 3. So this time, we need to find a coordinate where to start. So to start, you can look at this -3. We know in slope-intercept form, it's y equals x plus b. So the number that we're adding per se is -3. We're actually subtracting. So that means our y-intercept, or b, is going to be -3. So we're going to plot a point at 0, -3 on the y-axis. You see that? And so to get the second point, though, we need to recognize that even though there's nothing in front of that x, it actually does have a slope. Remember, if there's just one x, our slope is 1. So our slope is going to be 1 over 1. So we're going to do rise over run. So you're going to go up 1 over 1, up 1 over 1, up 1 over 1. We have some points here that we can plot. Okay, and then we're going to put a line through it. And you can see that it hits the y at -3 and it has a slope of 1. All right, the last one is proportional. I know that because it has nothing being added. So it's the format y equals m times x. M is my slope, and m is 1 is my rise, and 4 is my run. Okay. If it's proportional, another important thing to remember is that I know it's going to go through the origin. Because it's proportional, it's going to start at 0, 0. Right? So we could say this is +0 because nothing's been added. So our starting point is actually going to be 0, 0. And then we're going to do our rise over run. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. And then you're going to plot your points. It's going to go through the graph, just like that. And you can see it's proportional, and it starts at 0, 0. So be careful because they're going to be all mixed up on your test. You're going to have some that give you points and slope, some that give you points and y-intercept, and some either give you the slope or the y-intercept, and you have to figure out what to do from there. All right, section 5. So for this, I'm going to use, it says to use the Desmos. So I'm going to pull up my Desmos calculator here. And what you're going to do is you're actually going to put in this expression here because you're trying to see if the x values are going to give you the y value using that function. So on my Desmos, I'm going to click A over B, and I'm going to put 1 fourth, and then make sure you click out of there, and I'm going to put x, okay? So I'm trying to see if these x values, so this is our x value, this x value gives you this y value. This, I'm trying to see if this x value will give me this y value. This x value gives me this y value, so on and so forth. Okay, so if I'm going to go, if I want to use my Desmos, I'm going to go to my next line, and I'm going to give it the first one, x equals 0. So I'm going to tell it x equals 0. And you'll see, when I put in x for 0, or 0 for x, I get that 0 value for y. So this would be a point that works. So that one works, okay? So now that we've typed in our expression, now I'm just going to change. I'm going to look at this one here. Now I'm going to try 1 and see if I get 4. So I'm going to back up, and I'm going to put 1. And if I do that, I get 0.25. So 0.25 is not the same as 4. So I'm going to cross that one out. It doesn't work. All right. Now I'm going to go to the next one down here. I'm going to put in 4 and 1 and see what I get. So if I put in 4 for x, look up here, I get 1 for y. So this one here is also going to work. And then I'm going to try the last one. It has negative 4 for x, so I'm just going to put a negative in front of the x I've already typed. And I get negative 1. So that's 1. I was trying to get negative 1. So this one is not going to work. You may not have to use Desmos every time. You might be able to do these mentally, think in your head. But Desmos is a good tool that you can use. So let's look at a couple more. So this one, y equals x plus 5. I'm going to do like I did before, and I'm just going to type in x plus 5. And I'm trying to get to see if these values work. So if I go to my next line and I tell Desmos that x is equal to, remember right here, there's a 0. So I put 0. If I put in 0, what do I get for y? Well, right here it tells me I get 5. I did not get 0. And it's because it's additive, not proportional, so I'm going to X it out. Okay, so let's try this one. I'm going to put in my x value right here, which is negative 1. So I'm going to put in negative 1 for x and see what I get. Look, I put in negative 1 for x, just like this negative 1 over here, and I'm trying to see if I get my y value. And I do, because that's a 4. So I'm going to circle this one and keep going. Now I'm going to put in 3 for x so I can keep my expression the same. And I'm just going to change my x value right here. And I'm going to put in 3. And if I put in 3, look, I get 8. That's what I'm trying to get, because 3 plus 5 is 8. So I'm going to circle this one. The next one, I'm going to put in 0, right? I have a 0 here. If I put in 0, 0 plus 5 is 5. It gives me that y value. So that one's also going to work. Now again, I know most of you are going to know 0 plus 5 is 5, and you may do some of this mentally. Desmos is especially helpful when we have the fractions or when we have negative numbers. So let's finish up with the last one. I'm going to clear this out. And I'm going to put in this expression, 3x. So I'm going to put in 3x. And I'm going to go to my next line, and I'm going to say, what if x is 1? X equals 1. So if x is 1, do I get 3? Or negative 3? No, I get 3. So this one is not going to work. What if x is, let's look at the one down here. What if x is 3? Let's try that. If I put in 3 for x, do I get 9? Yes, I do. X is 3, then y must be 9. So now we have a decimal, 0.5 and 1.5, so I'm going to see if that one works. So if I do, 0.5 times 3 is 1.5, so that's going to work. And then my last one here, 2 to negative 6, I'm going to put in 2, and I get positive 6. So that one's not going to be an option. So again, these are just plugging in the numbers and looking at the relationship and seeing if they're equal to the relationship that's given in the equation. All right, now we're going to put it all together. We're going to look at two examples, and we're going to try to figure out how they match up. So we have a graph and we have coordinates. So you can see, hopefully you see from this, that this is an additive relationship. It's additive because it does not start at 0, 0. Okay, that might be important. If I look at the graph, now I'm going to look at the different tables. First, I'm going to look at this table. I'm going to plot 0, 3. That's there. 1, 4. So I'm just plotting these. And then 2, 5 is there. So that works. But I'm going to try the other table too. 3, 0. So if I take 3 on the x and 0 on the y, it doesn't work. 4 on the x, 1 on the y, it doesn't work. And then 5 on the x, 2 on the y, it doesn't work. So I know that this is the correct table. Now, I'm looking for the one that has a relationship that shows that Jenny is 3 years older than Alvin. So I'm looking for a 3 years older relationship. If that's going to match, that's going to be a +3 relationship. And Takis are $3 per bag. That's going to be a ×3 relationship, right? Because 3 years older is we're adding 3, and $3 per bag is we're multiplying by 3. So what we're going to do here is we're going to try to figure out which table matches that relationship. So, because we already know the table, so we're going to look over at the first one, and you can see that the first one is a +3, right? Because 0 + 3 is 3, 1 + 3 is 4, 2 + 3 is 5, so that one's going to work. This one here is a -3 relationship. 3 - 3 is 0, 4 - 3 is 1, and 5 - 3 is 2. So you should have selected the table by looking at the coordinates here, and then the scenario because you know it's a +3. Okay, the other way you could know that it's a +3 is because it starts. Remember what we did with the equation. So the equation for this would be y = x + 3. And then y, the y-intercept, is +3. And if you look over here, my y-intercept is +3. So we have all these different representations that we're going to match up. All right, let's look at the last one. So now we're matching a table to a graph. Okay, a couple of things that we could do. We could look at the points. We could make an equation from each of the tables. I would say the best way to start would be to just match the coordinates. So I'm going to use a different color. So I'm going to start with red with this table. So I'm going to use red. So I'm going to go 0, 0. I'm just plotting my points. It's there. 4, 1. Let's see if that's there. 4 on the x, 1 on the y. Yes, because remember it's x then y. And then 8, 2, I'm not sure because it would go off the graph. So I'm going to put a little question mark there. So I'm going to go on and try some of the other ones, and then we can go back and look at that. So this one I'm going to use blue. So I'm going to go this first one here, 1, 4. So 1 on my x, 4 on my y. It doesn't work. So I can go ahead and eliminate that graph. The last one I'm going to use green. So again, 0, 0. We know it has it because it worked for the first table. And then 4, 1. It also works there. 4, 1. And then I have a 5, 2. 5, 2. Look what happened there. That line, or excuse me, that coordinate is not on the graph. So this must be the right answer. Okay. The other way we could check that all of the points are on the same line is we can look at the relationship between the ones that we know. So if you look at the relationship between 4 and 1, it's going to be divided by 4, right? Is 8 divided by 4 2? Yes. So we can conclude that that's on the line as well. Now the last thing, the bonus, is we're going to write the equation for the line. So the first thing I want you to think about is if it's proportional or additive. All right, it's proportional. So since the graph is proportional, I know I'm going to use the equation y = mb, or mx, excuse me. M being our slope, right? To get our slope is equal to rise over run. So now I'm going to look back at the graph, and I'm going to find 2 points and do my rise over run. So I'm going to go ahead and pick some that I already have. So I've got this point, and I've got this point, and I'm going to go up 1. So my rise is 1. And I'm going to go over 4. So it's 1/4. So my slope, so m, is going to be equal to 1/4. So my equation of the line is going to be y equals 1/4 x. Because dividing by 4 is the same thing as multiplying by 1/4. I could do my y divided by x if I wanted. There's lots of different strategies that we could use. All right, that's it for our Unit 5 test review.